All right, in the last video we did examples where we were figuring out the pH of a weak acid solution. Now we're going to do one that is a weak base solution. So what we're going to do first is we're going to check the assumption. Okay, so you take the concentration divided by the Kb value since it's a base, and we get 2.8 times 10 to the fourth, which is what, 2,800? Or 28, yeah, 28,000 actually, which is significantly bigger than 100, which means that we can assume that this minus x when we get to that point in the problem is equal to 0.5, so we can make this easier. The assumption works, okay? So since this is a base and this is a Kb, our reaction is going to look like this. We have our base plus water. It forms an equilibrium. Since this is a base, it's going to steal an H+, so you get NH4. And this is going to lose an H+, so we get OH-. Since it's forming OH-, that's our indication that this is a base. So, ice method. Our initial concentration is 0.500. We can ignore water the whole way through, and these are 0. We don't have any of that stuff yet. Okay. This is going to have to decrease by some amount, and this is going to have to increase by that same amount. For every one of these, you get one of these and one of these. So, the equilibrium conditions are you basically add these two columns together, or two rows together. Okay. Kb is equal to products over reactants raised to the coefficients, we can ignore the water, at equilibrium. So I'm just going to take the equilibrium conditions divided by this, and we have the Kb value, so 1.8 times 10 to the negative fifth equals x squared over 0.500 minus x. Because the assumption is true, we can basically ignore that. Okay, because the assumption is less than that, we can assume that 0.5 minus x is just 0.5, which makes the math considerably easier. Basically multiply 0.5 on both sides. That cancels out, and we get x squared equals this stuff. So we take the square root of both sides. I'm going to switch sides to make it a little more obvious what's going on here, but it's the square root of those two numbers multiplied together. Okay, so when you plug that all in, we get a value of 3.0 times 10 to the negative third molar. The reason this is useful is in this particular case, because this is a base, x is equal to the concentration of OH-. So we're going to have to take the POH first because pH is the negative log of H3O+. We don't have H3O+, we have OH-. So POH is the negative log of the concentration of OH-, which we just solved for, is 3.0 times 10 to the negative third. Okay, and so the POH comes out to 2.52. The question asks, what is the pH? To get pH, we take 14 minus the pH, or POH. And I got 11.48, which is above 7, which means that we got a basic solution. Seems completely reasonable here. Okay, so you'll notice that for a base solution, the main differences are, because it is a base, we're forming OH- instead of H3O+. The assumption part's the same, this part's all the same, except that you're solving for POH first, and then you have to subtract it from 14 to get pH. But otherwise, same basic idea of what we're doing. Let's try one more variation before we move on to something else. So let's try one where we're not solving for we're not solving for pH. Let's try one where we're solving for like Kb. Okay. So if a solution of CH3,2NH has a concentration of 1.64 and a pH of 11.98, we want to know what is Kb. Okay, well, we're going to set up the ice method table exactly the same, but this time we're not solving for concentrations, we're solving for Kb. So we're going to need all the concentrations at equilibrium. So the balanced equation is CH3 2NH is our base. We know it's a base because the pH is almost 12, plus water. Forms an equilibrium where this is going to steal an H+, so we get CH3 2NH2 plus OH minus. Okay. The initial conditions are 0.164 for this compound and zeros for everything else. We're ignoring the water. The change is this is going to decrease by some amount and those are going to increase by some amount. And equilibrium is going to be 0.164 minus x, and this is going to be x, and this is going to be x. And we're ignoring the water. Now, in previous problems, we've done the assumption to see if we can get rid of this x, but we don't even have Kb, so the assumption is this divided by Kb, and we don't have Kb, so we literally can't do the assumption here, but honestly, we don't need it. What we need to do is get this x value. The x value is equal to the concentration of OH minus, and because we have pH, we can solve for POH and then solve for OH minus. So let's work through that. pH, we said, is 11.98. To get POH, we subtract it from 14. Okay. And POH is equal to the negative log of concentration of OH minus, which is our x value. Okay. But we know POH, so we can plug it in. So 2.02 equals the negative log of, I'm just going to put it as x because that's x is concentration of OH minus in this problem. So, showing the work here, I guess I'll use a different color. We need to get rid of the negatives. So we need to get rid of this negative log. We have to get rid of the negative first. So this side's going to be negative, this side's going to be positive. Basically, we multiply both sides by -1. To get rid of the log, this is log base 10. So like we've seen in other problems, if you have log base 10, the secondary function, I don't know what you guys can say, is 10 to the x. So 10 to the whatever on both sides. That's going to cancel out. And so x is essentially equal to 10 raised to the -2.02. And that value comes out to 9.55 times 10 to the -3rd molar. So, since we know x, we can plug it in here, and here, and here, and plug everything in. So, Kb is equal to products over reactants. So, the products are both x's, so I'm going to write that as x squared, divided by 0.164 minus x. Okay, great. Now that we know what x is, we can plug this in. So 9.55 times 10 to the -3rd squared divided by 0.164 minus 9.55 times 10 to the -3rd. Okay. And we plug everything in and we see what we get. Okay. If you type all this in, I guess I'll actually do the legwork here. Sorry. 9.55 e to the -3rd squared. Okay, that's the top part. Divided by 0.164 minus 9.55 e to the -3rd. And I got 5.90 times 10 to the -4th. And that's our Kb value. Okay. All right. Thank you.